All right, let's start looking at the warm-up here. So again, we already know that these polygons are similar. And on number 4, we need to find this angle right here. I already see between the two trapezoids in number 4 that they have a corresponding congruent angle because they both have this 90-degree angle marked in the corner. Because they're similar polygons, all the angles are going to be congruent. What would be congruent to this 82-degree angle down here? Which angle would that be? Top left. So this right here would also be 82 degrees. What other angle do we know? $115, and that would go in the only blank spot that we've got, 115 degrees. Those would be congruent. So we have 90, 82, 115, and X. So we did mention yesterday, because I know all the angles in a triangle add up to 180 degrees. What do the angles in a four-sided figure add up to? 360. Angles in a four-sided figure add to 360 degrees. And so we're going to add those angles together. We're going to add 90, 82, 115, and X. And we'll set that equal to 360 degrees. So after I get my initial equation set up, we're going to combine our like terms together. 90, 82, and 115 would add together to give me what? I got something close, but not that. I got 287. Maybe just double check on your calculator, because I know sometimes I'll type some things in incorrectly. 287 degrees plus X equals 360. Then we need to subtract 287 from both sides. And that means X is how big? 73. So X is 73. Perfect. On number 5, we don't need to find an angle, but we do need to find this side right here where the X is. That means I need to set up a proportion of sides. We're going to have two fractions that we set equal. And I'm going to put the thing that I'm looking for, the X, I'm going to put that on the top of this first fraction here. X on my top triangle corresponds to what on the bottom triangle? Which side on the bottom triangle? 8. So I have X over 8. And then I need to make another proportion with the other two sides. What would need to go in the numerator of my second fraction? 21. And so the denominator would therefore have to be 12. X is part of a fraction. What do we do to get rid of fractions? Get rid of the denominator. What operation will get rid of that denominator? Multiplication. So let's multiply both sides by our denominator of 8 here. It's going to cancel the denominator on the left. It's only going to distribute to the denominator or to the numerator on the right. So I would have X equals, what's 21 times 8? 168 divided by 12 is what? It's 168 divided by 12. 14. Is X supposed to have units with it? Yes, what kind of units? Meters, so 14 meters. All right, then the last one on the warm-up, number 6. we are supposed to find z, which is right here. That is a side, so again, I'm going to have to make a proportion of sides. Let's put that piece that we're looking for up on top. So z up on top. What would that correspond to on the other trapezoid? 45. So z and 45 have to make a fraction together because they are corresponding sides. What would need to go up in the numerator of my second fraction? 20. Z went in the numerator of my first fraction. All the other numerators would have to come from the same trapezoid. So I have to have 20 up here. And that would correspond to what on the other trapezoid? 36. Z is part of a fraction. What operation gets rid of fractions again? Multiplication. And what part of the fraction do we multiply by? Denominator. So let's multiply both sides by the denominator of 45. It's going to cancel my denominator here. It's only going to distribute to the numerator over here. So I have z equals, what is 20 times 45? 900. So I have 900 over 36. What is 900 divided by 36? 25. Do we need units with that 25? Did z have units with it? What were those units? Inches. So 25 inches. Very nice work on the warm-up. You can go ahead and put that away for today. We're going to be in your extra notes packet. Again, we're on that very last piece of paper. We need to be on the front side of it because we still had one more piece to finish up there. And then we'll be on the very back page. So last piece of paper in the packet, front side of that last piece of paper, exactly where we left off yesterday. I'm going to do a brief run through of the things that we covered yesterday in our notes, and then we'll do that piece at the bottom. So yesterday we were talking about parts of similar triangles, and we talked about altitudes. If I have two similar triangles, and I have the altitudes for both of those triangles, those altitudes are proportional to, so I make a fraction with the altitudes, they're proportional to corresponding sides. So like the 5 and the y would make a fraction together, and that would be equal to the 4 and the 6 in a fraction together. Or the 4 and the 6, the altitudes, that fraction would be equal to the 3 and the x in a fraction. Those would be corresponding sides there. So altitudes are proportional to corresponding sides. Then we talked about angle bisectors. Angle bisectors cut angles into two equal parts, cuts them in half. If I have two similar triangles and I have the angle bisectors for both of those triangles, those are proportional to, so the 4 and the 10 here, because those are my angle bisectors, would make a fraction together. And that would be proportional to corresponding sides. So the 7 and the C, or the 3 and the A. So my angle bisectors would make a fraction, and then a pair of corresponding sides would make a fraction. The other thing that we can look at with angle bisectors when we're talking about similar triangles is if I just have one triangle, and that angle bisector is splitting my one triangle into two smaller triangles, like we have in this picture over here. The side that is being cut by that angle bisector is proportional to the adjacent sides. So 3 and 4 would make a fraction together, and then the 9 and the x would have to make a fraction together. And there was one more part that we needed to talk about today, and that is medians. One thing I want you to add on your paper, please, for whatever reason, on your paper, these two congruence marks did not print. Not quite sure why, but they did not print. So please go ahead and add those congruence marks to that larger triangle. And that means that those segments are the same size. This one over here says it is x, so this one over here would also be x. On my other triangle, we have congruence marks again. This one is 3, so this one here would also have to be 3. A median, let's remind ourselves of what a median is. A median goes from a vertex to the midpoint of the opposite side. From a vertex to the midpoint of the opposite side. So this segment right here in the middle of this triangle, I know that that has to be a median because it's going from a midpoint, and where it hits the opposite side, it's splitting it into two equal parts. So that is hitting the median of the opposite side. Same thing on this larger triangle over here. It's going from a vertex to the midpoint of the opposite side. And again, I know that because it's dividing that side into two equal parts. So that means this is a median. Corresponding medians are proportional to corresponding sides. So my medians are 4 and 8. So I'd make a fraction with the 4 and the 8. That is proportional to corresponding sides. Question. On this smaller triangle, how big is this entire side over here? 6. What about on the larger triangle? How big is this entire side? 2x. So my medians, 4/8, would be proportional to corresponding sides. So 6/2x. Or we could look at this pair of corresponding sides, 7 and 14. Or I don't have to look at this entire side because the two pieces of this side are the same size because I'm hitting the midpoint. I can look at just one part of each of these. So that would also be equal to 3/x. Can 4/8 reduce? What does 4/8 if I reduce that fraction down? 1/2. What about 7/14? Can that reduce? What does that reduce down to? Also 1/2. We said these things were equal. 1/2 is equal to 1/2, right? So I can see that the medians are proportional to that top left side. It's also proportional to that third side, the one that we have marked as 6 and 2x, or the side that we have marked as 3 and x. I want to show that it doesn't matter whether we look at that entire third side or whether we just look at it from the midpoint over. Let's solve each of these. So I'm going to solve this proportion, and we're going to solve this proportion. So I have 1/2 equals 6/2x. X is part of a fraction. What would we use to get rid of a fraction? Multiplication. What part of the fraction do we multiply by? Denominator. So let's multiply both sides by, you said 2x. That's one of my denominators, so we can absolutely do that. It's going to cancel this denominator. It's going to distribute here. So I would have 2x/2 equals 6. And then we need to multiply by our other denominator, which is just 2 by itself. What is 6 times 2? 12. I'm going to scoot my work over here. So I have 2x equals 12. And then we divide both sides by 2, because I want to get the x by itself. 12 divided by 2 is what? 6. If we did it with just half of that third side, from the midpoint over, so that I have 1/2 equals 3 over x, I should get the exact same thing for x. So we're going to multiply by our denominator. Which denominator do you want to multiply by first? X sounds good. You can multiply by either denominator first. So you can multiply by the x or by the 2. It distributes up to my numerator only. So I would have 1x, which is the same thing as just x, over 2 equals 3. And then we multiply both sides by our last remaining denominator of 2. And 3 times 2 would give me? Six. So either way, if I have that whole side and I can compare it to the whole side on the other triangle, we can set up our proportion that way. Or if I only know the distance from the midpoint over, I can set it up that way. Let's flip to that back page and try a couple practice problems with these. So first I'm going to ask what part of the triangle we've got, and then how do we set that up? So on number 4, this line right here from A to D, what would we call that? Is that an altitude, an angle bisector, or a median? An angle bisector. I know that's an angle bisector because when I look up here at A, it's being split into 2 equal parts there. How many angle bisectors do we have in this picture? Just the one. When I have a triangle and I just have one angle bisector, I'm looking for a split side. I'm going to look for where the angle bisector hits the opposite side. So that's right here at D. And the 2 sides of that, so the 12 and the 14, those are proportional to their adjacent sides. So I need to set up a fraction with the 12 and the 14. Which one should go on top? 14, 12, we get to make this choice. 14 sounds good. 14 over 12. That is proportional to their adjacent sides. So if 14 is on the numerator of my first fraction, then its adjacent side has to go in the numerator of the second fraction. What is adjacent to 14? 40. Remember, adjacent means next to or touching. So 40 would have to go in the numerator of my second fraction. And then 12 is in the denominator. What is adjacent to the 12? X. So that would have to go in the denominator of my second fraction. Then we want to solve this for x. X is part of a fraction. To get rid of fractions, we use multiplication, and we always multiply by what part of a fraction? Always the denominator. I've got 2 denominators here. We have to pick which one we want to do first. Do you want to multiply both sides by 12 first or by x first? X sounds good. There is no wrong choice there. You have to make a choice. Cancels out my x on the right-hand side. It only distributes up to that numerator of 14. So I would have 14x over 12 equals 40. Then we multiply by our other denominator. We multiply both sides by 12. Cancels out my second denominator, so I get 14x equals what? 480. And then we divide both sides by 14. And 480 divided by 14 is what? Let's round it out to, let's take it out to 3 decimal places. Yep, absolutely correct. Oh, good grief. Hold on, let me get all of this to move. Because I need just a smidge more space here. There we go. So we get x is equal to, you said 34 point what? 286. What about if the directions had asked us to leave this in fraction form? That means I would need to reduce this fraction down. Can you guys see anything that'll go into both 480 and 14? 2 would go into both of them. What is 480 divided by 2? 240. What about 14 divided by 2? 7. And then I gotta see if that'll reduce anymore. What kind of numbers go into 7? 7 and 1, right? I already know that 7 doesn't go into 240 because when we divided it on our calculator, we got this decimal right here. So that would be the fully reduced fraction form. All right, let's look at part B now. In the middle of these triangles, this segment from A to X, this other segment from D to Y, what would those be called? Are those altitudes, angle bisectors, or medians? Altitudes. They form a right angle with the opposite side. They go from a vertex and they make a right angle with the opposite side. That means these are altitudes. All right, let's add our measurements in here. It says AB is 22. So this side right here is 22. It says AX is 18. That's this altitude here. DY is 15. So that's this altitude on the other triangle. And we are supposed to find ED, this side right here. If I don't know how big it is, what could I call it? X. Altitudes are proportional to corresponding sides. How big are the altitudes again? 18 and 15, so I have to make a fraction out of those two. I need you to sit up here. We got to make a fraction out of the 18 and the 15. We get to decide which number goes on top. Which one do you want on the top, the 18 or the 15? 15 sounds good. That's the first thing I heard. There is no wrong choice there. All right, so 15 over 18. For my second fraction, my corresponding sides, I need the side that goes with 15 in the other numerator, because 15 is in my numerator here. What should go on the top of this second fraction? X. And on the bottom of the second fraction? 22, the corresponding side on the other triangle. So then we're going to solve this for X. Multiplication is what undoes fractions. You guys okay if we multiply by the 22 first? You get to pick a denominator. Does not matter which denominator you choose. So let's multiply both sides by 22. It's going to make my denominator on the right side cancel. I have 22 times 15, which is 330 over 18 equals X. And now, because these are just numbers, 330 divided by 18, I can pop that into my calculator. What is 330 divided by 18? 18.3 repeating. I'm curious if we can reduce 330 over 18. What would go into both 330 and 18? What'd you say? 2 goes into both of them. What is 330 divided by 2? 165. And 18 divided by 2? 9. I have to see if that's fully simplified now. So 9 is the smaller number. Let's start with that. What kind of numbers go into 9? 3 and 9, right? Can 3 go into 165? Yes. What is 165 divided by 3? 55. And 9 divided by 3? 3. So 18.3 repeating, or 55 over 3 is equal to x. We're writing it in both forms because you need to make sure you pay attention to the directions when we get to the test on Friday, whether it wants your answer back in decimal form or fraction form. If it doesn't specify, you get to decide whether you're going to give your answer back in fraction form or decimal form. If it does specify, if it says round your answer, and you're not quite sure what the word means afterwards, it says round your answer to the nearest tenth or to the nearest hundredth, and you're like, I don't remember how many places that is. If you don't remember how many decimal places it is, if you give me 3 decimal places, that will always be enough. I'm never going to ask for more than 3 decimal places. All right, let's go look at number 5, next to last problem. First of all, this line right here in the triangle. What part of the triangle would that be? What would we call that there? An angle bisector. It's splitting this top angle into 2 equal parts, so that is an angle bisector. So I need to look at my divided side. That would be this side down here. That divided side is proportional to the adjacent side. So I need to make a fraction with the x and the 7. Thank you, sir. So I would have x over 7 is equal to, and now I have to do the adjacent sides. What side is adjacent to x? 24 is adjacent to x. X touches the side that is 24, so that would need to go in the numerator of my second fraction. And then what would be adjacent to the 7? 20. What'd you say? We are in the notes packet, yes. So 20 would need to go in this denominator. What should my first step be now? Seven. What with the 7? Multiply by 7. Multiplication gets rid of fractions. We always multiply by the denominator, so we're going to multiply both sides by 7. That distributes up here to my 24. What is 24 times 7? 168 over 20. What is 168 divided by 20? How much? 8.4. Could we reduce 168 over 20 so that we could write it in its fraction form instead of decimal form? What goes into both 168 and 20? What would go into both 168 and 20? Will 4 go in? Double check. Let's see if we can make 4 go into it. You said yes? What is 168 divided by 4? You said 42? And 20 divided by 4? 5. So 8.4 or 42 over 5. We have one last problem to look at together, and then we are done with your entire Module 8 notes packet. So my first question, similar to before, is these line segments that are in the middle of our triangles or inside those triangles. Are those altitudes, medians, or angle bisectors? These are medians. Medians are proportional to corresponding sides. So I'm going to set up a fraction with my medians. X and 33 need to make a fraction together. Doesn't matter which one you put on top. So I'm doing x over 33. We knew these were medians because where they're hitting the opposite side, they're splitting them into two equal parts. X and 33 are my medians. These two sides are corresponding sides. One is 10, one is 15. So we're going to make a fraction with the 10 and the 15. Which one would have to go up on top? Which one would go up on top? The 10, because it's coming from the same triangle that X is. And so 15 would have to go down in our denominator. To isolate X, what do we need to do? Multiply. What did you want to multiply by? 15 sounds good. There's not a wrong choice when you're multiplying by a denominator. If you want to multiply both sides by 33 first, you may absolutely do that. So that gets rid of my denominator here. That 15 distributes up to the x. So I would have 15x over 33 equals 10. And then what do I need to do? Multiply by 33. We got to multiply by our other denominator to get rid of it. So that's going to cancel the denominator on the left-hand side. So I have 15x equals what? 330. Last thing we need to do to isolate x. Divide. What are we dividing by? 15. So like this. Why is that wrong? The x doesn't go in my denominator. I want the x to stay on the left-hand side where it is. So I only divide by the 15, not by the x. So I get x equals, what is 330 divided by 15? 22. X is 22. Very, very nice work on the notes today. The homework that you guys picked up on the way in the door yesterday is due tomorrow. That is the very last homework of this entire section, this module. Tomorrow when you guys come in, you'll work on a warm-up while I check homework. Then we'll grade and correct that last homework assignment. We'll go over the warm-up, and then you guys will have the remainder of the time to work on the test review, which will be in the tray when you guys come in tomorrow for you to pick up. Thursday, I'll take any questions you have over the test review, and then our test is on Friday.